My name is Nakabari Benjamin, and I'm going to talk about the cache memory, but specifically about the mapping function and the replacement algorithm. First, I'm going to talk about the brief introduction to cache memory. A cache memory is a high-speed memory between the CPU and the main memory. And because there are fewer cache lines than main memory blocks, an algorithm is needed for mapping blocks into cache lines. But first, I'm going to talk about the mapping function. This mapping function describes where a particular block can be placed when it goes into the CPU cache. And in the cache memory, there can be a cache hit or a cache miss. A cache hit occurs when the requested data can be found in a cache, while a cache miss occurs when it cannot. The first mapping function I'm going to talk about is the direct mapping, and this maps each block of main memory into only one possible cache line. Based on the address of the memory block, it can only occupy a single cache line. And the advantages of direct mapping: it is power efficient as it avoids the search through other cache lines. It requires cheap hardware as only one tag needs to be checked at a time. And the disadvantages of direct mapping: there is a fixed cache location for any given memory block. The second mapping function I'm going to talk about is the associative mapping. And this associative mapping overcomes the disadvantages of direct mapping by permitting each main memory block to be loaded into any line of the cache. And each cache slot consists of two parts, a tag and the actual data. The actual data is the one which holds the content of the block. And the tag contains a portion of the memory address that uniquely identifies each block of data stored in that slot. And the advantages of associative mapping: it provides flexibility of placing memory block in any of the cache lines. It also provides better cache hit rate. And also the disadvantages of associative mapping: it is slow as it takes time to iterate through all the lines. It consumes power as it has to iterate over the entire cache set to locate a block. And also it is very expensive due to the high cost of associative comparison hardware. And the last mapping function I'm going to talk about is the set associative mapping. This exhibits the strength of both the direct and associative approaches while reducing their disadvantages. Cache consists of a number of sets which contain a number of lines. A given block maps to any line in a given set, and a memory block is first mapped onto a set and then placed into any cache line of the set. And the advantages of set associative mapping is that it offers the flexibility of using replacement algorithms if a cache miss occurs. And the disadvantage of set associative mapping is that there is an increased comparison time. Now I'm going to talk about the replacement algorithms. The first replacement algorithm I'm going to talk about is the first in, first out. And here the cache evicts blocks in the order in which they were added, regardless of how often they were accessed before, and replaces that block in the set that has been in the cache longest. And secondly, there is the least recently used, and this one replaces the block in the set that has been in the cache without reference to it. This algorithm requires edge bits for cache lines and tracks the least recently used cache line based on them. And the other replacement algorithm is the least frequently used. This one replaces that block in the set that has experienced the fewest references, counts how often an item is needed. Those used less are discarded first. And the last replacement algorithm is the random replacement. This selects an item and discards it to make space. This algorithm does not require keeping any access history, and it is mostly used in the ARM processors. That has been my presentation about the mapping function and the replacement algorithms in cache memory. Thank you.